In this lesson, we'll review function and introduce function notation. Standard California Common Core Standard. Understand that a function from one set to another set assigns to each element of domain exactly one element of the range. If f is a function and x is an element of its domain, then f of x denotes output of f corresponding to the input x. The graph of f is the graph of equation y equals f of x. And another California Common Core Standard: use function notation, evaluate functions for inputs in their domains, and interpret statements that use function notation in terms of a context. Objective students will be able to state whether a relation is a function and use function notation to find range of a function with a given domain. Review function or not a function. State whether the following relations are function or not a function. So given x maps onto y, we see 1 maps onto 3 and 1 maps onto 4. 2 maps onto 4 also. We see 1 is repeated, the domain 1 is repeated. It maps onto 1 and 4. So this is not a function. This is not a function because domain is repeated. Domain is repeated. X value equals 1 is repeated. It goes to 2 y values. Next example, 1 maps onto 5 and 1 maps onto 6. 2 maps onto 6, the same situation. This is not a function because the domain is repeated. Domain equals 1 is repeated, goes to 2 y values. Not a function. Review vocab. Relation, any set of ordered pairs, so x and y. Function, a type of relation where for every x there is exactly one y. So if a function is where the x value is not repeated, you won't see same x value for a different y value. Function can be represented 5 different ways: table, graph, mapping, set of ordered pair, equation. Example, state whether y equals 3x is a function. So we are going to complete table of values and then use mapping. So the domain for this function I chose was -2, -1, 0, 1, and 2. You can pick any values for domain. Then we find y value and then we do the mapping for input and output. Make sure our x is not repeated and the input is not repeated. So x over input is domain. So if domain is repeated, it's not a function. Let's complete our table of values. We have y equals 3x. We want to plug in y equals 3 times -2. That's -6. 3 times -1 is -3. We want to find value of y when x is 0. So 3 times 0 is 0. We want to find value of y when x is 1. So 3 times 1 is 3. Then we want to find the value of y when x is 2. So 3 times 2 equals 6. So those are the range. We just found our range. Now we'll go and map. So when we map our table of values, we see one input goes to one output, exactly one output. One input goes to exactly one output. It doesn't go to two different outputs. So our domain is not repeated. Therefore, this is a function. This is a function. In next example, this state whether the equation is a function. So given y equals absolute value of x. When we take absolute value, that means we are finding the distance from 0. And distance cannot be negative. Distance can never be negative. So therefore, when we take absolute value of a negative number, it is a positive number. And when we take absolute value of positive number, it still remains a positive number. So y equals absolute value of x. Now, if x is -2, y will be 2. It's 2 here, positive 2. When x is -1, the absolute value of -1 is 1. When x is 0, the absolute value of 0 is 0. When x is 1, absolute value of 1 is 1. When x is 2, absolute value of 2 is 2. So we just found our y values, the range, the output. Now we are going to map and see if it's a function or not a function. So when we map our values we found in the previous slide, we can see one domain goes to one y value. We can see the range is repeated, the output is repeated, but the domain is not repeated. So domain is not repeated, therefore this is a function. the previous example, we found absolute value of x. Now we are going to find absolute value of y. So we chose our range. We are going to find domain. Will it be any different? Let's see. So we want to find x, absolute value of y. So we have first y value -2. So when we take absolute value of -2, we have 2. When we take absolute value of -1, it's 1. When we take absolute value of 0, still 0. When we take absolute value of 1, absolute value of a positive number is always positive, but absolute value of a negative number, the sign will change, it will become positive. And then absolute value of 2. Now you can see in domain 2 and 1 are repeated. 2 and 1 are repeated. So when we write in the input, when we are going to map, we'll just say 1, 2, 3. We won't write it, we won't repeat the numbers, we'll write it only once. So when we map our numbers, we found in the previous slide, when we map our domain and range, the input and output, we can see x equals absolute value of y is not a function, because you can see 1 Another example, tell whether the relation below is a function. So number 1, input and output, we can see the mapping. So each input goes to same y value. 0 goes to 6, 1 goes to 6, 2 goes to 6, 3 goes to 6. Here the range is repeated, but it doesn't matter for it to be a function. Range can repeat. Domain should not be repeated. So the domain is not repeated in this case. The input is not repeated. X value is not repeated. Therefore, this one is a function. Number 2, you can see -3, the x value is -3. Same x value goes to different y values. The domain is repeated. The x value is repeated. So therefore, this is not a function. Number 3, you're given a graph. You need to find it's a function or not a function. We perform vertical line test. When we do our vertical line test, we can see the vertical line crosses the graph more than one time. Anywhere on the graph you draw, you can see at some places it crosses more than one time. So what it is telling us is domain is repeated. Therefore, this is not a function. The x value is repeated. Therefore, this is not a function. Number 4, you can see -2 goes to 1 and -2 goes to 2. -2 is repeated. Therefore, this is not a function. These are the solutions from the previous slide that I was explaining. state domain and range of the given graph. So we are going to complete table of values for this given graph where it says x and f of x. F of x is just y. F of x is just y. F of x is just y. So when you have -2, when x is -2, y is, or f of x is 5. So -2 is 5. When your x is -1, f of x is 4. -1, 4. When your x is 0, f of x is 3. 0, 3. When x is 1, f of x is 2. 1, 2. When x is 2, when x is 2, f of x is 1. 1. X is 2, f of x is 1. Now we want to list our domain and range. So domain is the x values. You have -2, -1, 0, 1, 2. We have to make sure it's from smallest to largest. Our domain, sorry, our range f of x. Our range f of x, the y value is 1, 2, 3, 4, 5. And this graph is a function if we draw a vertical line test, or we can say domain is not repeated. Each domain has a unique range, or exactly one range. Function notation is compute the following. Given y equals to x plus 1 and f of x equals to x plus 1. It's the same thing, y equals to x plus 1 or f of x equals to x plus 1. Y equals f of x. So we need to compute for x equals 1, 2, 3, 4, or f of 1, f of 2, f of 3, f of 4. Begin with y equals to x plus 1. And find the y values. So we have 2 times 1 plus 1, which is 2 plus 1 is 3. So 2 times 1 is 2, plus 1 is 3. Then we have, when x is 2, 2 times 2, plug in the equation, plus 1. So 2 times 2 is 4, plus 1 is 5. When x is 3, we plug in 3 in place of x. We have 2 times 3 plus 1. So 2 times 3 is 6, plus 1, 7. Then when x is 4, we plug in 4 in place of x in the equation. So we have 2 times 4 plus 1 equals 2 times 4 is 8, plus 1 equals 9. So now our range is 3, 5, 7, and 9. Now we have to find f of x equals to x plus 1. We have to see how it is different from y equals to x plus 1, or are they same. We begin with putting 1 in the equation when x is 1. what is f of x. So 2 times 1 is 2 plus 1 is 3. And then when x is 2, what is f of x? Plug in 2 in place of x. 2 times 2 is 4 plus 1, which is 5. When x is 3, what is the value of f of x? So we plug in 3 in place of x and simplify. So 2 times 3 is 6 plus 1 is 7. When x is 4, what is f of x? So we plug in 4 in place of x and simplify and find value for f of x. So 2 times 4 plus 1. 2 times 4 is 8 plus 1 is 9. So the f of x values for corresponding x values are 3, 5, 9. 3, 5, 7, 9. So we can see when we plug in the x values 1, 2, 3, 4 in y equals 2x plus 1 and f of x equals 2x plus 1, we have same y values. For example, x equals 1, y value is 3 and f of 1 is 3 also. If x is 2, y equals 5, f of 2 equals 5. If x is 3, y equals 7, f of 3 is 7. If x is 4, y equals 9, f of 4 is 9. So they are same. It's just written different way. Another example, given g of x equals x squared, h of x equals 2x minus 1. Find the following: 1 g of 4, 2 h of negative 2, 3 g of negative 3, 4 h of 5, 5 h of 4 plus g of 1. So you have to find the h of 4, then find g of 1, add them together. 6 h of negative 5 g times g of negative 2. So find h of negative 5, find g of negative 2 and multiply them together. 7 g of h of 3. So first we find h of 3, then plug in the value of h of 3 in g of x. Number 8, h of g of 2. So first we find the value of g of 2 and then plug it in h of x. Now we compute the values. So g of x equals x squared means x times x. Doesn't mean 2 times x, common mistake people make. It's x times x. So if we want to find g of 4, so it's 4 squared, plug in the 4 in place of x. So x is 4, you plug it 4 in place of x, you have 4 times 4. 4 times 4 is 16. Now h of x equals 2x minus 1, which is a linear function. But here we want to find h of negative 2. That means x is negative 2. So plug in negative 2 in place of x. We have 2 times negative 2 minus 1. 2 times negative 2 is negative 4. Minus 1 is negative 5. Now number 3 says g of x is negative 3. So x is negative 3. We want to plug negative 3 in g of x in x, where it's negative 3 squared, which means negative 3 times negative 3, which is 9. Now we have to find h of 5. That means x is 5. We plug in 5 in place of x. So you have 2 times 5 minus 1. 2 times 5 is 10 minus 1, which is 9. Question 5. We will have to find h of 4 plus g of 1. So we find h of 4 first, which is 2 times 4, 2 times 4 minus 1 plus, we need to find g of 1, which is 1 squared. So 2 times 4 is 8 minus 1 plus 1 times 1 is 1. So you have 8 minus 1 is 7. 7 plus the 1 is 8. Now question 6, we want to find h of negative 5 times g of negative 2. So first we find h of negative 5. Then we find g of negative 2 and multiply them together. H of negative 5. H of negative 5. We have 2 times negative 5 minus 1 times g of negative 2, which is negative 2 squared. I have negative 10 minus 1 times negative 2 times 2. Negative 2 times negative 2. So you have negative 10 minus 1 is negative 11 times negative 2 times negative 2 is 4. So negative 11 times 4 is negative 44. The 7 says find g of h of 3. So first we find h of 3. First we find h of 3. H of 3, which is 2 times 3 minus 1, which is 6 minus 1 is 5. Now h of 3 is 5, so we plug it in g. So we find g of 5, which is 5 squared, which is 5 times 5, which is 25. So this is 25 here. The question 8 says h of g of 2. So we find g of 2, then plug it in h of x. G of 2 is 2 squared, which is 2 times 2, which is 4. Now we want to find h of 4, which is 2 times 4 minus 1, which is 8 minus 1, which is 7. Write the function over the domain x equals negative 1, x equals 0, and x equals 2. We're just going to plug it in place of x those numbers. Given g of x equals 4x minus 1, given g of x equals 4x minus 1, we want to find when x equals negative 1. So we have g of negative 1 equals 4 times negative 1 minus 2. So 4 times negative 1 is negative 4 minus 2 will give you negative 6. Negative 6. And you want to find when x is 0. When x is 0. When x is 0, what is g of 0? 4 times 0 minus 2. 4 times 0 is 0, minus 2 is negative 2. And you want to find when x equals 2. When x equals 2, what is g of 2? Which is 4 times 2 minus 2. 4 times 2